guys, I don't want to do my college apps, so I'm gonna be doing this stat problem instead. Um, just this is gonna require like some knowledge of statistics. Well, not even like just probability in general. So let A and B be independent events where the probability of A is 0.4 and the probability of B is x. The probability that at most one of A or B occurs is 0.72. So what we need to do is find x, and then given that at most one of A or B occurred, what is the we need to find the conditional probability that B occurred. So immediately I was drawn to like this second sentence here. I don't know, the wording was just like weird for me. So the best way to think about this is in terms of like a Venn diagram. Where it reads better if you think about it like the probability of everything but the intersection between the two probabilities, right? Like that makes sense. So because it's at most, that means we can think of like the probability that nothing occurs, or the probability that only A occurs, or the probability that only B occurs. So what we're left with is like this intersection in the middle, if you can even tell there was an intersection there. But now that that's been established, we can look at P of at most one, and this is equal to 1 minus the probability of A and B. And that makes sense intuitively, right? Like the probability of everything minus the probability of both is the probability of all the rest, which is everything but. And because these two are independent events, you can just multiply these together, which would be 0.4 times x, just gives you x. So 1 minus this is equal to that. And because the probability of at most 1 is 0.72, we can set this equal to 0.72. And then you just end up solving for x, right? So what we can do is just subtract and add to either side. So what we end up with is 0.28 equals 0.4x. If you divide both sides by 0.4, you should get 0.7 equals x. And that would be our answer. So let me just write that up here. And then I'll just erase this because now it's like mostly unnecessary. Okay. The second part of the problem. Now that we solved for number 1, yeah, okay. Given that at most one of A or B occurred, what is the conditional probability that B occurred? So we just need to find the probability that B occurred and only B, given that at most one of A or B occurred. So basically it just turns into this, the probability of B given A. Yeah, and then this would just be like the conditional probability, right? That was an arrow if you couldn't tell. And this obviously is equal to the probability of B. Okay, that looks like a D. B and A over the probability of A. But notice here, this is actually going to be a not. Like the, maybe I'm not I'm not qualified enough to be doing these because it's the complement, right? Okay. It's actually going to be the complement because we're looking for the probability. Okay. I mean, do I need to? Yeah, I should probably explain why. What we're looking for is essentially the probability that B occurs and A doesn't, right? That like just B occurred, and the A complement means it's not, like as in A does not occur alongside B. So what we can use, I mean, yeah, it makes sense, right? Like, we have what, okay, this ties in, I promise. So the probability of B is equal to the probability of B and A complement. Okay. Okay. I give up. And A complement plus the probability of A and B. Right? That makes sense, right? The probability of B is equal to the probability of, I mean, you want to think about it in terms of like a Venn diagram again, right? The probability of, let's say this one is B. The probability of this entire like circle, right? That would be equal to the probability of B complement A, which is this shaded area, and the probability of A and B, which is this area. So that makes sense. And what we now need, okay, now we just need to solve for this, right? So we can just get the probability of B, which was 0. That doesn't look like a, so 0.7 minus the probability of A and B, and the probability of A and B is 0.28. So minus P of A and B, and how I got 0.28 was, I mean, because they're independent events again, it would be 0.7, which is B, times 0.4, which is A, and you get 0.28. So what I get for P of B over A complement is 0.42. Now that we have 0.42, we can just slide that over 0.72, and unfortunately I'm not a calculator, but I think this turns into 7 over 12. Okay, so I mean that's the end, right? So we found x is 0.7, and then using that we were able to find the second part of the question, and we can confidently say that the conditional probability that B occurred is 7 over 12. Thank you guys.